The afternoon sun beat down on the Capoterra airfield in southern Sardinia as ground crew members rushed toward the twin-engine fighter that had just landed. It was June 12th, 1943, and the aircraft sitting on the tarmac should not have been there. The distinctive twin-boom silhouette of the Lockheed P-38 Lightning was unmistakable, but instead of American markings, this aircraft bore none at all. The pilot who climbed out was not an American. Lieutenant Colonel Angelo Tondi, chief test pilot of the Regia Aeronautica, Italy's Royal Air Force, stood before this prize that had literally fallen into Italian hands. The American pilot had suffered a compass failure during his flight between Gibraltar and Malta, a 30-degree navigation error that had brought him hundreds of miles off course and directly over Italian-controlled territory. Out of fuel and with no other options, he had landed at the first airfield he saw. Within hours, the P-38G had been seized, the pilot taken prisoner, and Tondi had been summoned to examine this gift from the sky. As Tondi circled the aircraft, running his hand along the smooth aluminum skin, he understood immediately what he was looking at. This was not just another enemy fighter. This was everything Italian aviation had been trying to build for years and had consistently failed to achieve. The twin Allison V1710 engines, each producing 1,200 horsepower. The concentrated firepower in the nose, one 20mm cannon and 4 50-caliber machine guns. The sophisticated turbochargers that allowed the aircraft to maintain power at high altitudes. The long range that made it suitable for escorting bombers deep into enemy territory. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Tondi had spent his entire career around Italian aircraft. He knew their strengths and their weaknesses, intimately. He had flown the Mach C-200, a competent fighter hampered by inadequate armament. He had tested the Fiat G50, underpowered and undergunned even by 1940 standards. He had pushed the Regia Re 2000 through its paces, a design that showed promise but suffered from chronic engine problems. And now, standing before this American Lightning, he understood with brutal clarity the chasm that separated Italian aviation from what the Americans had achieved. The P-38 was ordered flown to Guidonia Airfield, just northeast of Rome, home to the Regia Aeronautica's primary flight test center. Over the following weeks, Italian engineers would swarm over this aircraft, measuring, documenting, analyzing every system. They would pit it against every fighter in the Italian arsenal in mock dogfights. They would test its performance at various altitudes, its turning radius, its rate of climb, its dive characteristics. They would fire its guns, examine its ammunition storage, study its electrical systems and hydraulics. But what they discovered would not bring them hope. It would bring them despair. The story of Italian aviation in World War II is not a story of incompetent engineers or cowardly pilots. Italian aircraft designers were among the most talented in the world. Italian pilots had set numerous speed records in the 1920s and 30s. The Regia Aeronautica had performed impressively in the Spanish Civil War, in Libya, in East Africa. On paper, Italy should have been an aviation powerhouse. In reality, by 1940, when Mussolini dragged Italy into war alongside Germany, the Regia Aeronautica was a small fleet flying mostly obsolete aircraft, powered by engines that couldn't compete, supported by an industrial base that couldn't produce what was needed. The fundamental problem was one that no amount of engineering skill could overcome. Italy lacked the industrial capacity to build modern engines. Without the powerful, reliable engines, every other aspect of aircraft design became an exercise in compromise. You could design the most aerodynamically perfect airframe in the world, but if you only had 840 horsepower engines available when your opponents were fielding 1,200 horsepower or 1,475 horsepower engines, you had already lost before the first shot was fired. This engine crisis had its roots in decisions made years before the war. In the early 1930s, Italy had 4 companies producing air-cooled radial engines. Fiat based their designs on American technology. Alfa Romeo licensed Bristol designs from Britain. Isotta Fraschini and Piaggio both used French Gnome Rhone designs. This fragmentation of effort meant that resources and expertise were spread across too many competing projects. No single company could achieve the scale needed for truly modern development. The standard Italian fighter engine by the late 1930s was the Fiat A74, an 14-cylinder radial producing somewhere between 840 and 870 horsepower. This engine powered Italy's most numerous fighter, the Fiat CR-42 Falco biplane. Yes, a biplane. In 1940, when Britain had Spitfires and Hurricanes, when America was developing the P-38 and P-51, Italy's frontline fighter force consisted primarily of open cockpit biplanes with fixed landing gear. The CR-42 was maneuverable and its pilots were skilled, but it was fundamentally obsolete before Italy even entered the war. Italian engineers understood this. They had designed monoplane fighters with retractable landing gear. The Macchi C-200, the Fiat G50, and the Regia Re 2000 all entered service around 1940. These were modern designs by the standards of the mid-1930s, but they suffered from the same crippling limitation: inadequate engine power. The Macchi C-200 used an 870 horsepower Fiat, a 74 engine, giving it a top speed of just 312 miles per hour. The Fiat G50, powered by an 840 horsepower engine, could barely reach 293 miles per hour. Compare this to what the Allies were fielding. The Supermarine Spitfire, powered by a Rolls-Royce Merlin engine producing over 1,000 horsepower, could exceed 360 miles per hour. The American P-40 Warhawk, with its 1,200 horsepower Allison engine, reached 364 miles per hour, and the P-38 Lightning, with its twin 1,200 horsepower engines, could hit over 400 miles per hour at altitude. Italian fighters weren't just slightly slower, they were catastrophically outmatched. The armament situation was equally dire. The standard Italian fighter armament consisted of two 12.7mm Breda Safat machine guns. That was it. Two heavy machine guns. The P-38 had four 50-caliber machine guns, which were comparable to the Breda Safat, plus a 20mm cannon. The Spitfire carried 8 30-caliber machine guns, or, in later variants, two 20mm cannons. German Bf-109s typically mounted two machine guns and one or two 20mm cannons. Italian fighters simply couldn't deliver enough firepower to reliably destroy enemy aircraft, especially the heavily armoured bombers that would increasingly dominate the war. But it was the industrial situation behind these inadequacies that truly doomed Italian aviation. Italy had entered the 20th century as a largely agricultural nation. Its rapid industrialization had focused on textiles, light manufacturing, and shipbuilding. Heavy industry existed, but on a far smaller scale than in America, Britain, or Germany. The Italian automobile industry, which would prove so crucial for aircraft engine development, barely existed. In the 1930s, Italy produced only a few thousand automobiles per year. America produced millions. This meant Italy lacked both the machine tools and the skilled workforce needed for mass production of complex mechanical systems like aircraft engines. The problem wasn't just scale, it was resources. Italy had virtually no domestic petroleum deposits. Its iron ore, coal, and strategic metal reserves were minimal. Any modern war machine required massive imports of raw materials, but Italy's geographic position made this difficult. The British Royal Navy controlled the Mediterranean. American submarines would soon prowl the shipping lanes. Every ton of steel, every barrel of oil, every piece of copper had to run a gauntlet just to reach Italian shores. And even when materials arrived, Italy's fuel situation created insurmountable engineering constraints. Italian aviation fuel was B4 grade, rated at approximately 87 octane. This compared to the 91 octane fuel the Americans used as standard and the 1 to 100 octane fuel that powered British fighters by 1940. Higher octane fuel allows higher compression ratios and supercharger boost pressures, which directly translates to more power from the same size engine. Italian engineers trying to design more powerful engines were fighting physics itself. You simply cannot extract 1,500 horsepower from an engine when the fuel will detonate prematurely under the pressures required. This fuel limitation infected every aspect of Italian engine development. Engineers at Alfa Romeo, Fiat, and Piaggio worked on larger 18-cylinder radial engines that should have produced 1,400 to 1,500 horsepower. The Alfa Romeo 135, the Fiat A80, the Piaggio P-12. On paper, these engines matched what the Americans and British were achieving. In practice, they were disasters. The Alfa Romeo 135 suffered from catastrophic vibration problems because the designers had eliminated the center bearing to save weight. The engine would literally shake itself apart under sustained operation. The Piaggio P-12 was so unreliable that crews of the few aircraft equipped with it, like the Pone 108 bomber, lived in constant fear of engine failure. The engines overheated, leaked oil, suffered gasket failures, and required constant maintenance that was impossible to provide in field conditions. The Fiat A80 weighed just 615 kilograms for a 45.7-litre 18-cylinder engine. This was remarkably light for its size, a testament to Italian engineering ingenuity. But the engine produced only 1,000 horsepower, and only briefly. It couldn't sustain high power output without overheating. It required meticulous maintenance. And, most damningly, it was never produced in meaningful numbers because Italian industry simply couldn't manufacture the precision components required at scale. Production numbers tell the stark story of Italian aviation's industrial crisis. The most successful Italian fighter of the early war years was the Fiat CR-42 biplane. Total production, under 2,000 aircraft. This was Italy's most numerous fighter. Germany produced over 33,000 Bf-109s. Britain built over 20,000 Spitfires. America would eventually produce nearly 15,000 P-38 Lightnings alone, not counting tens of thousands of other fighter types. Italian fighter production for the entire war was measured in hundreds per type, sometimes just dozens. The reasons were systemic. Italian aircraft factories were small, scattered across the country and Italian-controlled territories. They relied on skilled craftsmen hand-fitting components rather than the mass-production assembly lines that characterized American and even German industry. Where American factories could stamp out standardized parts by the thousands, Italian factories required workers to individually fabricate and adjust each piece. This was slower, more expensive, and resulted in parts that weren't truly interchangeable between aircraft. Mussolini's corporatist economic policies made everything worse. High tariffs protected Italian industry from foreign competition, which sounds good until you realize it also prevented Italian companies from importing better machine tools, higher quality materials, or more advanced manufacturing equipment. State-owned enterprises like IRI controlled much of the aviation industry, and these bureaucratic behemoths were more concerned with political favoritism than with efficient production. Contracts were awarded based on connections rather than capabilities. Multiple companies competed for the same limited government funding, fragmenting resources further. And then there was Fiat. As Italy's largest industrial concern and one of the nation's biggest employers, Fiat had learned to manipulate Mussolini's fears of labor unrest to maintain its dominant position. Fiat directors, some of whom were also government members, ensured that Fiat received favorable treatment even when its products were inferior. The result was an aviation industry that produced some of the most obsolete and lowest quality materiel of World War II, not because Italian engineers were incompetent, but because the system they worked within made excellence nearly impossible. When the captured P-38 arrived at Guidonia, Italian test pilots immediately began comparative trials. They flew the Lightning against the Macchi C-200, against the Fiat G50, against the Regia Re 2000 and Re 2001. The results were sobering. The P-38 was faster than any Italian fighter. It climbed faster. It had better high-altitude performance. Its armament was devastating. Its range was 3 times greater than most Italian fighters. In every measurable category except low-speed maneuverability, The American aircraft was superior, but the most shocking revelation came when Italian engineers examined the P-38's power plants. Each Allison V1710 engine was a masterpiece of American automotive engineering applied to aviation. These were liquid-cooled V12 engines, benefiting from decades of American experience building automobile engines. The engineering tolerances were tight, but not impossibly so. The materials were high quality, but not exotic. The cooling systems were effective without being overcomplicated. Everything about the engines screamed robust, reliable, maintainable. These were engines designed to be mass-produced by semi-skilled workers using standardized manufacturing processes, then installed in aircraft by mechanics in the field, operated hard by pilots in combat, maintained under difficult conditions, and still deliver consistent performance. Italian engines were nothing like this. Italian radials required constant adjustment. Valve clearances had to be checked frequently. Oil consumption was high. Cooling was marginal. Reliability was poor. And the liquid-cooled engines Italy tried to develop, like the Isotta Fraschini Delta and Zeta, never reached the performance or reliability levels needed for frontline service. Italian pilots joked bitterly that they feared their own engines more than enemy fire. At least against enemy fire, you could take evasive action. Against a failing engine at 10,000 feet over water, there was nothing you could do but pray. The solution Italy finally adopted was both pragmatic and humiliating. They bought German engines, or rather, they license-built them. The Daimler-Benz DB601, a 33.9-litre inverted V12 producing 1,075 horsepower, became the Alfa Romeo RA1000. The more powerful DB605 became the Fiat RA1050, called the Tifone. These German-designed engines finally gave Italian fighters the power they desperately needed. The Machi C200 2 Folgore, powered by the license-built DB601, achieved 372 miles per hour and could actually compete with British fighters on relatively equal terms. When the even better Machi C205 Veltro appeared in early 1943, powered by a DB605 derivative and armed with German MG-151 cannons in addition to Italian machine guns, Italy finally had a fighter that could match Spitfires and American P-51 Mustangs in performance. But it was too late, far too late. The Machi C202 only entered service in summer 1941, a full year after Italy entered the war. The Machi C205 didn't arrive until early 1943, and only 177 had been delivered by September 8, 1943, when Italy signed an armistice with the Allies. Of these, only 66 were still operational. Production of truly competitive Italian fighters measured in dozens or at best hundreds, arriving years after they were needed, facing an enemy producing thousands of equivalent or superior aircraft every month. Part 2 of 3. The industrial mathematics were merciless. In 1942, at the peak of Italian aircraft production, the Regia Aeronautica managed to produce approximately 1,100 aircraft of all types. That same year, the United States produced over 47,000 aircraft. Britain produced over 23,000. Even Japan, with an industrial base smaller than America's but larger than Italy's, produced over 8,500 aircraft. Germany, fighting on multiple fronts, still managed over 15,000. Italy's entire annual production was less than what American factories could produce in 2 weeks. The bomber situation was equally disastrous. Italian bomber development had followed a peculiar path driven by the same engine limitations that plagued fighters. Unable to produce engines powerful enough to propel twin-engine bombers at competitive speeds, Italian designers often resorted to 3-engine configurations. The Savoia Marchetti SM-79 Sparviero was actually a successful design by Italian standards. This 3-engine medium bomber, powered by 3 1,000-horsepower Piaggio P11 radials, achieved 270 miles per hour and had exceptional range. It performed well as a torpedo bomber in the Mediterranean, sinking considerable Allied tonnage. but the SM-79 was a pre-war design that flew its first mission in the Spanish Civil War. By 1940, it was already obsolete compared to American and British bombers, and the engines that powered it, those supposedly 1,000 horsepower Piaggio radials, were notoriously unreliable. Crews hated them. The engines overheated constantly. Oil leaks were endemic. Engine failures were so common that pilots considered 3 engine configurations necessary for safety rather than performance. If one engine quit, you still had 2 to limp home on. The Canzone 1007, another 3-engine bomber, used the same unreliable engines and suffered the same problems. The Piaggio Pone 108, Italy's only 4-engine heavy bomber, was powered by 4 Piaggio P-12 18-cylinder radials that produced 1,350 horsepower each at altitude. On paper, this gave Italy a strategic bomber comparable to the American B-17 or B-24. In reality, only 24 Pone 108 bombers were ever built. The engines were so unreliable that the aircraft was more dangerous to its own crews than to the enemy. Engine fires claimed multiple aircraft. Maintenance requirements were crushing. Of the 24 built, only a handful ever flew combat missions before Italy left the war. Lieutenant Colonel Tondi understood all of this when he prepared to fly the captured P-38 inches, combat. On August 11, 1943, just 2 months after the aircraft had been captured, word came that American B-24 Liberator bombers were returning from a raid on Terni in Umbria. Approximately 50 heavy bombers, flying in formation, heading back toward their bases in North Africa. This was Tondi's chance to test the Lightning's capabilities in actual combat and to strike a blow against the enemy using their own weapon against them. Tondi took off from Guidonia in the captured Lightning, its aluminum skin now marked with Italian insignia. The twin Allison engines roared with a power no Italian fighter could match. The rate of climb was astonishing. Within minutes, Tondi was at altitude, scanning the sky for the bomber formation. The P-38's cockpit was spacious compared to Italian fighters, the visibility excellent. The concentrated nose armament meant no need to calculate convergence points like fighters with wing-mounted guns required. Everything pointed straight ahead. Point the nose, press the trigger, and that devastating firepower went exactly where you aimed. Tondi spotted the formation and positioned himself for an attack run. He had the speed advantage. He had the altitude advantage. He had firepower that no Italian fighter could deliver. An Italian Machi C-202 or C-205 had already attacked the formation, doing minimal damage. The Machi's 2 12.7mm machine guns and occasional 20mm cannon simply couldn't deliver enough metal into a B-24 to bring it down quickly. The Liberator was a huge, tough aircraft. Its 4 Pratt & Whitney R1800 engines gave it redundancy. Its armour protected the crew. You needed concentrated heavy fire to kill a B-24, and most Italian fighters couldn't provide it. The P-38 could. Tondi opened fire on one bomber, walking his rounds through its fuselage and wings. The 450 caliber machine guns, each firing 850 rounds per minute, combined with the 20mm Hispano cannon, delivered a storm of metal. The B-24 shuddered under the impacts. Smoke began trailing from one engine, then another. The bomber fell out of formation, losing altitude. 6 crew members bailed out, their parachutes blossoming in the sky over the Tyrrhenian Sea near Anzio. The aircraft crashed offshore near Torvaianica. It was a kill. A confirmed B-24 destroyed, using an American fighter against American bombers. But it was also the first and last combat mission the captured P-38 would fly. The problem was fuel. Italian aviation gasoline, that low-octane B4 grade, was too corrosive for the P-38's fuel system. The Lockheed engineers who designed the Lightning had optimized every component for American fuel specifications. The fuel tanks, the lines, the seals, the gaskets, all were designed for the less corrosive American fuel. Italian petrol was eating through seals, contaminating the fuel system, and creating a maintenance nightmare. Without spare parts, without the correct fuel, The captured Lightning was grounded permanently. It sat at Guidonia for the remaining weeks until Italy's armistice, a monument to what Italian industry could not provide. But the real story of the P-38's evaluation at Guidonia wasn't about that single combat mission. It was about what Italian engineers learned during their weeks of testing and analysis. They learned that American engineering philosophy was fundamentally different from Italian or even German approaches. The P-38 was not a minimalist design trying to extract maximum performance from limited resources. It was not an over-engineered marvel like German designs that pursued perfection at the cost of practicality. It was a robust, reliable, maintainable weapon designed for mass production and sustained combat operations. Every system in the P-38 told the same story. The electrical system used standardized components that could be replaced in the field. The hydraulics were simple and accessible. The turbochargers that gave the Lightning its high-altitude performance were derived from commercial technology. The counter-rotating propellers eliminated torque effects, but used gear systems that mechanics could service without specialized tools. The aircraft was designed to be built by automobile workers, maintained by mechanics with basic training, flown by pilots with reasonable instruction, and still deliver lethal effectiveness day after day, mission after mission. Italian aircraft were the opposite. They required skilled craftsmen to build. They needed specialized mechanics to maintain. They demanded expert pilots to fly effectively, and even then, they couldn't match the performance of enemy aircraft. The CR-42 biplane required an ace to survive against a Hurricane or Spitfire. A mediocre pilot in a CR-42 was simply dead. The Macchi C-200, flown by a skilled pilot, could hold its own against a Hurricane in a turning fight but would be destroyed by a Spitfire with any altitude advantage. The Fiat G50 was so underpowered that it could barely catch enemy bombers, much less fight escort fighters. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The comparison trials at Guidonia revealed specific technical details that Italian engineers found both fascinating and depressing. The P-38's Allison engines used a single-stage, single-speed supercharger combined with an exhaust-driven turbocharger. This gave excellent power at altitude, without the mechanical complexity of multi-stage superchargers. Italian engines used single-stage superchargers without turbochargers, which meant they lost power dramatically at altitude. Above 15,000 feet, Italian fighters were gasping for air while the P-38 maintained nearly full power past 25,000 feet. The structural design of the Lightning also revealed American engineering philosophy. The aircraft was built in sections that could be manufactured separately and then joined. This modular construction meant that multiple factories could produce components simultaneously, then ship them to assembly plants for final integration. Damage to one factory wouldn't halt production because other factories could continue making their components. Italian aircraft, built in small factories by craftsmen, couldn't achieve this kind of distributed production. Each factory built nearly complete aircraft from start to finish. Bomb one factory, and you lost its entire production capacity. The P-38's range was perhaps the most impressive feature to Italian observers. With drop tanks, the Lightning could fly escort missions covering over 400 miles to the target and back. Italian fighters were lucky to have a combat radius of 150 miles. This meant Italian fighters couldn't escort bombers on deep strikes. It meant they couldn't intercept enemy bombers until those bombers were already over Italian territory. It meant Italian air superiority was limited to a narrow radius around Italian air bases. The strategic implications were devastating, but understanding what the Americans had achieved didn't help Italy build it. That was the cruel lesson of the captured P-38. Italian engineers could measure every dimension, analyze every system, understand every design choice. They could write detailed reports documenting American technical superiority. They could propose design changes to Italian aircraft that would allow them to compete more effectively. But they couldn't conjure the industrial capacity to implement any of it. Italy's aviation industry employed approximately 45,000 workers in 1940. This sounds impressive until you compare it to American aircraft industry employment of over 2 million workers by 1943. A single American aircraft factory complex might employ more workers than Italy's entire aviation industry. The Willow Run plant in Michigan, built to produce B-24 Liberators, employed 42,000 workers at its peak and produced one B-24 bomber every 63 minutes. Italy's entire aviation industry couldn't produce one bomber every 63 minutes. They couldn't produce one aircraft of any type every 63 minutes. The machine tools required for modern aircraft production simply didn't exist in Italy in sufficient numbers. Precision boring machines for engine cylinders, hydraulic presses for stamping aluminum components, specialized jigs for holding wing spars during assembly, riveters capable of working with the thin aluminum skins used on modern aircraft. Every one of these machines either had to be imported, which was increasingly difficult due to the British naval blockade and later American submarine campaign, or built domestically by an Italian machine tool industry that was already working at maximum capacity, trying to support tank production, ship construction, and small arms manufacturing. Raw materials presented equally insurmountable problems. Aluminum production in Italy totaled approximately 35,000 tons per year in the late 1930s. The United States produced over 250,000 tons. Germany produced 164,000 tons. Even with Italian-controlled bauxite mines in the Balkans, Italy couldn't produce aluminum at the scale needed for modern aircraft mass production. Every ton of aluminum that went into an aircraft was a ton not available for engines, not available for ships, not available for the thousands of other military applications competing for scarce materials. The shortage of strategic metals forced Italian engineers into creative but ultimately counterproductive solutions. They experimented with mixed construction, using wood for some structural components to save aluminum. They used steel in places where aluminum would have been preferable because steel, while heavier, was less scarce. They developed magnesium and zinc alloys that could be produced from materials mined in Italy. Some of these alloys were actually quite innovative, showing Italian metallurgical expertise. But innovative alloys couldn't solve the fundamental problem of insufficient quantity. Copper was another critical shortage. Electrical systems need copper wire. Radiators for liquid-cooled engines need copper. Italian copper production was minimal, requiring massive imports. By 1942, the British naval blockade and Allied submarine campaign had reduced Italian merchant shipping to a trickle. Ships carrying copper from mines in North Africa or the Balkans were being sunk faster than they could be replaced. Italian factories found themselves literally unable to wire aircraft because copper wire was unavailable. They tried aluminum wire as a substitute, which worked poorly. They tried to reclaim copper from civilian sources, asking Italians to donate copper pots, pipes, gates, any source of the metal. It was never enough. The fuel situation grew worse as the war progressed. Italy had always depended on imported petroleum. Romanian oil fields supplied much of what Italy needed, but transportation from Romania to Italy meant either rail through Germany and Austria, vulnerable to Allied bombing, or ship through the Black Sea, Bosporus, Aegean, and Mediterranean, running a gauntlet of British submarines and aircraft. By 1943, fuel shortages were so severe that the Regia Aeronautica had to ration training flights. Student pilots received minimal flight time. Operational squadrons conserved fuel by limiting patrols. Aircraft sat on the ground, not because they were damaged or under maintenance, but because there was no fuel to fly them. This fuel crisis created a vicious cycle. Without sufficient fuel for training, pilots arrived at combat units with inadequate experience. Inexperienced. Pilots made mistakes, got shot down, died needlessly. The need to replace these losses meant accelerating pilot training even further, which meant even less flight time per student, which meant even more combat deaths. By 1943, Italian pilot training had been reduced to a bare minimum. New pilots arrived at squadrons with perhaps 50 hours of total flight time, often less. American pilots might have 300 hours before seeing combat. The difference in survival rates was predictable and tragic. The captured P-38 forced Italian military leadership to confront an uncomfortable truth they had been avoiding. Italy could not win an air war against the Allies. The industrial disparity was too vast. The technological gap was too wide, and, most importantly, the gap was widening, not closing. Every month that passed saw American aircraft industry producing more planes, better planes, in quantities Italy couldn't match in a decade. British aircraft production was similarly expanding. Even the Soviet Union, having relocated its aviation industry east of the Urals to escape German invasion, was outproducing Italy by 1943. Italian aircraft designers did what they could with what they had. The Regia 2005 Sagittario, one of the so-called Serie 5 fighters that appeared in 1943, was an excellent design. Powered by a license-built DB605 engine and armed with three 20mm cannons plus two 12.7mm machine guns, it could match any Allied fighter in performance. Its semi-elliptical wing design was sophisticated and aerodynamically efficient. Test pilots loved flying it, but only 48 were ever built. 48 total, for the entire war. By comparison, America produced over 15,000 P-47 Thunderbolts in 1943 alone. 1 year of American production of just one fighter type exceeded Italy's total production of its best fighters by a factor of 300. The Fiat G55 Centauro was even better. Some who flew it considered it the finest Italian fighter of the war, superior even to the German Bf 109 in several aspects. It had excellent handling, good speed, heavy armament, and a robust structure. The Germans were so impressed they considered building it under license in Germany. But by the time the G55 entered production in mid-1943, Italy was collapsing. Only 105 were completed before the armistice. After Italy's surrender, both the Italian Social Republic in the north, fighting alongside Germany, and the Italian co-belligerent Air Force in the south, fighting alongside the Allies, used the few available G55s. But there weren't enough to matter. 100 fighters, scattered across two air forces fighting on opposite sides, facing thousands of Allied aircraft. It was futile. The Savoia Marchetti SM-92 deserves special mention because it's the aircraft that comes closest to the title's claim about copying the P-38. Designed by Alessandro Marchetti, the SM-92 was a twin-engine, twin-boom fighter that superficially resembled the Lightning. But it was not a copy. It was an independent design that happened to use a similar configuration. The twin-boom layout offered real advantages: excellent pilot visibility, concentrated armament in the central nacelle, and structural efficiency. Marchetti had used twin-boom configurations before on racing aircraft. The SM-92 was powered by two Fiat RA1050 Typhoon engines, the license-built DB605 producing 1,475 horsepower each. It was a large aircraft, actually bigger than the P-38. Initial test flights in late 1943 showed promise. The aircraft had good stability and control. Performance projections were competitive. But the Italian armistice in September 1943 occurred before testing could be completed. Italy's changing political situation, the Allied invasion, the German occupation of northern Italy, all created chaos that made continued development impossible. Only one prototype was ever completed. We'll never know if the SM-92 could have been a successful fighter, because history didn't give it the chance to prove itself. This single prototype, sitting incomplete while the nation collapsed around it, perfectly symbolizes Italian aviation's tragedy. Good designs, talented engineers, skilled test pilots. None of it mattered because the industrial foundation necessary to turn prototypes into production aircraft simply didn't exist. You can't build an air force on prototypes and good intentions. The combat record of Italian pilots demonstrates that the problem was never courage or skill. it was equipment. In North Africa, Italian Macchi C-200 fighters faced American P-40 Warhawks in late 1941 and early 1942. The Macchis, though badly outgunned and somewhat slower, could hold their own in turning fights. Italian pilots learned to avoid head-on attacks where the P-40's 650 caliber guns would shred their lightly armed fighters. They learned to use their superior maneuverability to force turning engagements where the Macchi's lighter wing loading gave them an advantage. But by late 1942, when P-38 Lightnings began appearing in significant numbers over the Mediterranean, Italian pilots faced an enemy they simply couldn't match. The P-38 was faster than any Italian fighter at all altitudes. It climbed faster. It could dive away from trouble. Its heavy armament meant that even a short burst could destroy an Italian fighter, and its long range meant that P-38 seconds could escort bombers deep into Italian-controlled territory, past the range where Italian fighters could effectively intercept. Italian pilots quickly learned that the P-38 was more dangerous than Spitfires. The Spitfire was faster than Italian fighters and better armed, but in a turning fight, a skilled Italian pilot in a Macchi C-202 or C-205 could sometimes force a Spitfire into a favourable position. The P-38 didn't turn as well as a Spitfire, but it didn't need to. Its speed advantage was so great that P-38 pilots could choose when to engage and when to disengage. If an Italian pilot got on a P-38's tail, the American simply pushed the throttles forward and left the Italian fighter behind. If a P-38 pilot wanted to engage, he could dive from above, make a high-speed firing pass, and zoom back up to altitude before the Italian fighter could respond. It was boom and zoom tactics perfected, and there was no defense against it when your aircraft simply couldn't keep pace. The psychological effect on Italian pilots was devastating. They went into combat knowing they were outmatched. They watched comrades die in aircraft that couldn't compete. They saw the endless stream of Allied aircraft, wave after wave, knowing that for every one they shot down, 10 more would appear tomorrow. The mathematics of attrition were hopeless, and yet they continued to fight because that was their duty. Italian fighter pilots in 1943 were among the bravest men in any air force. They climbed into obsolete aircraft and faced overwhelming odds because their country asked them to. When Italy signed the armistice on September 8, 1943, the Regia Aeronautica had approximately 1,000 aircraft of all types still operational. Of these, perhaps 300 were modern fighters, Macchi C-202s and 205s, Fiat G-55s, Regiane Re-2005s. The rest were obsolete by any standard. And even those 300 modern fighters, flown by the surviving skilled pilots who hadn't been killed in 2 years of combat, couldn't have affected the strategic situation. The Allies had thousands of aircraft in the Mediterranean theatre, thousands more in Britain preparing for the invasion of France. The disparity in numbers, in industrial production, in pilot training, in logistics, in everything that mattered, was so vast that Italian resistance had become purely symbolic. The armistice split Italian aviation just as it split the nation. In the south, the Italian co-belligerent air force was formed, flying alongside the Allies against Germany. In the north, the Aeronautica Nazionale Repubblicana, the air force of Mussolini's Italian Social Republic, continued fighting alongside the Germans. Italian pilots found themselves at war with other Italian pilots, flying the same aircraft types on opposite sides. The few modern Italian fighters were divided between both forces. Neither side had enough aircraft to matter strategically. Both became footnotes to a war being decided by American, British, and Soviet production. After the war, captured Italian aircraft were examined by Allied intelligence teams. The reports make for sobering reading, though not in the way one might expect. Allied engineers found that Italian aircraft design was actually quite competent. The Macchi fighters had good aerodynamics. The Fiat G55 was structurally sound and well conceived. Even the obsolete biplanes showed skilled design work within their limitations. But every report noted the same problems: inadequate engines, insufficient armament, poor quality control in manufacturing, and, most damningly, tiny production numbers. One American report concluded, Italian aircraft designers understood modern fighter requirements. Their latest designs could have been competitive if produced in quantity with reliable engines. The failure was not in design, but in industrial capacity. That single sentence captured the entire tragedy of Italian aviation in World War II. They knew what needed to be built. They understood the requirements. They simply couldn't build it. The irony is that post-war Italy, freed from Mussolini's autarky policies and corporatist economics, developed a thriving aviation industry. Italian engineers worked with American and British companies, learning mass production techniques. Italian factories imported modern machine tools. Italian metallurgists worked with high-quality materials. Within a decade, Italy was building jet fighters under license and developing indigenous designs that were exported worldwide. The talent had always been there. The problem had been a system that made excellence impossible. The captured P-38 Lightning sat at Guidonia airfield throughout those final chaotic weeks before Italy's armistice, a silent witness to the collapse of Mussolini's dreams of aerial dominance. Its aluminum skin, marked with hastily applied Italian insignia, gleamed in the Mediterranean sun. But it would never fly again. The corrosive Italian fuel had done its damage, and without spare parts from America, without the infrastructure to maintain it, the most advanced fighter Italy had ever possessed was reduced to a static display. Lieutenant Colonel Angelo Tondi would survive the war. After Italy's armistice, he flew for the co-belligerent air force in the south, this time genuinely fighting alongside the Americans rather than against them. He would eventually command units equipped with aircraft provided by the Allies, Spitfires, Mustangs, and eventually, years after the war ended, actual P-38 Lightnings delivered as military aid. When Tondi finally flew a properly maintained Lightning with the correct fuel in 1946, he understood even more clearly what Italian aviation had been missing. It wasn't just one component, it was everything. The story of that captured Lightning encapsulates everything wrong with Italian aviation during World War II. Italy had talented engineers who could recognize excellent design. They had brave pilots willing to fly obsolete aircraft against overwhelming odds. They had designers creating fighters that, on paper, could compete with the best the Allies fielded. What they didn't have was the industrial ecosystem to turn potential into reality. American aviation dominance didn't come from individual genius. It came from an industrial system that had spent decades perfecting mass production. From automobile factories that could be converted to aircraft production overnight. From steel mills that could pour the tonnage needed for thousands of aircraft. From oil refineries that could produce the high-octane fuel that made powerful engines possible. From machine tool manufacturers who could supply the precision equipment needed for modern manufacturing. From a workforce trained in factories that valued efficiency and standardization over craftsmanship. From a resource base that could sustain production without imports. From a geographic position that made blockade impossible, Italy had none of these advantages. Italian engineers trying to build competitive aircraft were like architects asked to design skyscrapers in a village that only had materials for building cottages. They could draw beautiful plans. They could understand the principles of structural engineering, but without steel girders, without concrete, without the cranes to lift materials into place, those skyscrapers would never rise above the planning stage. The captured P-38 proved this truth in the most brutal way possible. Italian engineers could examine every rivet, measure every dimension, understand every system. They wrote detailed reports that documented American technical superiority with painful precision. But understanding what America had built didn't help Italy build it. The Lightning required 1,200 horsepower engines that didn't detonate when supercharged. It required aluminum in quantities Italy couldn't produce. It required fuel Italy couldn't refine. It required manufacturing precision. Italy's craftsman-based factories couldn't achieve at scale. It required a logistics system that could supply spare parts to forward air bases. Most fundamentally, it required an industrial philosophy that valued reliability and maintainability over theoretical perfection. Japan faced similar problems trying to copy American tanks as they discovered with captured M3 Stuarts. Germany over-engineered the Panther tank into a maintenance nightmare, but Italy's aviation crisis was worse because aviation requires even more industrial sophistication than armoured vehicles. You can't hand-fit aircraft engines the way you might hand-fit tank components. You can't accept good enough quality control when one failed component at 10,000 feet means a dead pilot. Aircraft demand precision, reliability, and consistent quality that Italy's fragmented, under-resourced aviation industry simply couldn't deliver. By the time that P-38 was grounded permanently at Guidonia, the war was already lost for Italy. Not lost because of that specific aircraft, but lost because of what it represented, an unbridgeable gap between what Italian aviation needed to be and what Italian industry could produce. No amount of courage from pilots could overcome engines that failed. No amount of skill from designers could overcome lack of materials. No amount of brilliance from engineers could overcome an industrial base operating at perhaps 5% of American capacity. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The captured Lightning was eventually destroyed or scrapped during the chaos of 1943. No photographs of it survive. No detailed technical drawings made by Italian engineers have ever surfaced publicly. It exists now only in scattered military reports and the memories of the few men who examined it. But its lesson endures. In modern industrial warfare, understanding your enemy's weapons means nothing if you lack the industrial capacity to match them. Italy tried to compete with American aviation. They couldn't survive the industrial reality that came with that ambition.